Rationale for our project is in order to ensure that people's vehicles are parked properly and can access the structured parking spot are crucial component of a building system. Additional parking system is seen as a crucial component of the transportation network, typically associated with the building system in a way that makes it practical and accessible to owners, tenants, and anybody else using the space for business purpose. In addition, it offers building occupants in general convention by providing secure parking area for their cars. This is our case study. For the problem statement is the number of parking violation at lecturer parking. The correlation between the numbers of parking violation and parking space available at lecturer parking. The parking space to accommodate user at lecturer parking. And the objective of this project is to study the numbers of parking violation at lecturer parking, to investigate the correlation between the number of parking violation and parking space available at lecturer parking. And the last one is to determine the parking space to accommodate users at lecturer parkings.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I'm going to introduce you myself first. So my name is Wan Daniel Faruqi bin Roslan and my metric number is CN220090. So for the data presentation, in this project, the method that is used to collect data one by observing and recording for 2 days with 3 hours each. The collected data is the number of the cars illegally parked at the lecturers' parking lot at UTS Pago. So for day 1 on 21 December 2023, we started to collect our data at around 8 p.m. AM in the morning until 11 a.m. in the morning for 3 hours straight. So as you can see in the table, there are about 20 peak number that we collected, and the time from 0 until 2.75 hours. So as you can see, mostly in the morning there are many students that park at the lecturers' parking lot. So as you can see, from the early data that we collected, there is about 17 cars parked at the lecturers' parking lot. And so for the next slide is for day 2 on 22 December 2023. We started to collect our data at 12 p.m. until 3 p.m. for 3 hours. So as you can see in this table that we made, you can see that mostly students also started to park at the lecturers' parking lot around 0.5 until 1.75 hours. So as you can see, the value of the total cars that park around that time is 12, 16, 15, 14 until 12. Thank you. And next, I'm going to show you the data analysis that we collected from our observation on 21 December for 3 hours straight for the discrete statistic. So as you can see in the table, in the first table, you can see the time class, the midpoint, the frequency, f, fx, x2, and fx2 until fx in the bracket of 2. So as you can see, the total for the midpoint is 18 and the frequency is 124, and for fx you can see is 191.5, and for x2 the total for the value of it is 35.946, and for fx2 you can see the value is 393.895. So moving on to the next table, you can see the time class that we collected, midpoint, frequency. All the data collected is in the table. Thank you.
Okay, now I will explain the cumulative percentage of frequency against midpoint. So this is the graph. The graph is increasing from 19.71 to 100. Then the right side is the calculation. Okay, we start from mean. Mean equals to sum of fx over n equals to 191.5 over 124. So the answer is 1.53. Then median, 1 over 2 times 124 equals to 62. The class interval is 1.25 minus with 1.50. Okay, now is the mode. Mode is LM equals to negative 0.5, D1 equals to 17, and D2 equals to 10. So we use the formula to apply the D1, D2, and LM on it. So the formula is LM plus D1 over D1 plus D2 times C. Okay, so the equals to negative 0.5 plus 17 over 17 plus 10. So we complete the inside bracket first. So that is negative 0.5 plus 17 over 27. So the answer is 3.28. Now variance. For variance, we're using the formula also. So the formula is s square equals to sum of fx square minus bracket sum of fx square over sum of f, and divided by the sum of f minus 1. So equals to 393 or 393.895 minus with 4,368.55 or 124 over 124 minus 1. So when we calculate it, 393 over 895 minus with 35.230 over 123. So the answer is 2.92. Okay, the last one is the standard deviation. Also using formula, the square root of sum of fx square minus bracket sum of fx square over sum of f over sum of f minus 1. So after we calculate it, we got the power of square root of 2.92. Then after we calculate it, we get the answer is 1.71. This is the one of the data that we collected. Venue at the lecturer parking lot utilization Pago. The date is 22 December 2023. The time is 3 hours. That is from 12 p.m. to 3 p.m. So the time class, midpoint, frequency, fx, x square, fx square, and fx square. So the calculation, the total is the midpoint is 18, frequency is 127, fx is 198.125, x square is 35.946, fx square 376.089, and bracket fx square is 4143.675. Now is the graph section for cumulative percentage of frequency against midpoint. This is the graph that is starting from 2.36 until 100. So this is our calculation. First mean equals to sum of fx over n equals to 198.125 over 127 is equals to 1.56. Median is 1 over 2 times 127. The answer is 63.5. So the class interval is 1.25 minus with 1.50. So now it's mode. The LM that we got is 0.70, D1 is 3, and D2 is 0. So we use the same formula for previous, that is LM plus D1 over D1 plus D2 times C. So what the answer we get is 6.7. So now is variance. The formula also same as previous. That is s square equals to sum of fx square minus bracket fx square over sum of f minus 1. So equals to 376.089 minus 4143.675 over 127 over 127 minus 1. So after we calculate, we got the answer that is 2.73. And lastly is the standard deviation, using the same formula. S equals to square root sum of fx minus bracket sum of fx square over sum of f over sum of f minus 1. So square root 2.73 that we got, and the final answer is 1.65.
Right over here, we can see the busiest time for student is around the first 15 minutes with a frequency of 17 and the probability of 0.37 on the first table. On the second table, the busiest time of the day is around the first 45 minutes to 1 hour with a frequency of 16 and the probability of 0.126. This show that this two time of the day is the highest and the busiest day for students to find their parking spot. Alright, over here we get the calculation for day one and day two. For day one, we got the frequency of 17 and probability is 0.412. So first we find the mean. So to find the mean, we just multiply the frequency and the probability, which is 17 times 0.412, and we get the mean is 7.004. For the variance, it's just the mean times 1 minus the probability. So to find the variance, we just 7.004 times 1 minus 0.412, and we got 4.118. The standard deviation for day 1 is the square root of the variance. So square root of 4.118, we got 2.029. On the second day, we got the frequency of 23 with the probability of 0.348. To find the mean, we multiply the frequency and the probability. So 23 times 0.348 equal to 8.004. And to find and the variance for day 2 is 5.219. And the standard deviation is square root of 5.219 is equal to 2.285. So the literary analysis for both day, we find that the mean for the violation parking is 11.772 and the variance is 147.692 and the standard deviation for the both day is 3.019. So using the central limit theorem, we can say that the sampling distribution of X is approximately normally distributed. Thus, to find the average parking violation at the actual parking lot, which is less than 12 of n equals to 40, is excuse me is 0.6844.
So for hypothesis testing, we can conclude that we have two hypotheses that can show for the assignment. So for the first hypothesis, the number of car parking balloted during the afternoon day 1 and the morning day 2 are equal. And for the second hypothesis, we have number of car parking valuation during afternoon day 1 and the morning day 2 are not equal. The significant level is A equal to 0.05 and the test is two-tailed, so that we can say that W is less than or equal to critical Wilcoxon value. From the table, W given a significant level A equal to 0.05 and a number of pairs n equal to 12. So we can see that W critical is equal to 13. Since W is larger than the W vertical, we can reject HA, thus we accept the HO. Since states that the numbers of car parking validation during the afternoon day 1 and the morning day 2 are equal. We have the evidence to conclude that the numbers of car parking validation are similar during afternoon day 1 and the morning day 2. In conclusion, the objective of this case study are achieved in the study of the number of parking violation at lecturer parking. The investigation of the correlation between the number of parking violation and parking space available at lecturers parking, and determine the parking space to accommodate user at lecturer parking.